Good morning, students. Once again, we solve some additional problems. This is our 12th lecture. Two coherent light sources are 0.7 millimeter apart. So we have small d is equal to zero point 0.7 millimeter. If the center of the fourth dark fringe of the interference pattern formed by the light emitted from them on a screen placed at a distance 1 meter, that is capital D is 1 meter, and fourth dark. So I write x4 prime is equal to 3 millimeters, so 3 into 10 raised to minus 3 meter. Find the wavelength of the monochromatic light. So if the center is here, then I get this is center, then this is dark, then this is bright, then dark, bright, dark, bright, dark. So 1, 2, 3, and 4. Okay. So how much distance actually? So this is 1, 2, and 3. So distance, how much? What is the distance? So 3 lambda d upon d. So 3 lambda d upon d plus half. So x4 prime is equal to 3.5 lambda capital D upon small d. This is best way to find out this. Otherwise you can use formula also. પણ આવી રીતે drawing થી વધારે સારું પડશે. So now you have to calculate wavelength. So wavelength is equal to x4 prime small d upon lambda d, and this is 7 by 2. So I write 7 by 2. So sorry, I have to calculate lambda. Okay, so lambda. So we put all this value 2x4 prime is given 3 into 10 raised to minus 3. Then d is given by 0.7 millimeter 10 raised to minus 3 divided by 7 into capital D is 1 meter. So when you cancel, this is 0.1. So minus 3 minus 3 minus 7 minus 6 minus 7. So it is 6 into 10 raised to minus 7. So it is 6,000 angstrom. Okay. Then next one. In a young experiment, the distance between two slits and that between the slit and the screen are given. So you have given small d is equal to 0.05 centimeter. Remember, unit તમારે ખાસ care લેવાની કારણ કે આમાં લોચા પડી જાય. So this is centimeter, this is meter. Respectively, find the distance between third bright and fifth dark. I always use prime as the dark and without prime is the bright. So I have to find out this distance. Take the wavelength is equal to 5,000 angstrom. So into 10 raised to minus 10. Now it is in meter. This is multiplied by 10 raised to minus. So now it is meter. So it is already in meter. Okay. So third bright and fifth dark. What is the distance? Again, this is bright, then dark, then bright, then dark. Okay, this is dark, dark, bright, dark, bright, dark. So this is 1, 2, 3, 4, bright, dark, and this is fifth number dark. Okay, and my third bright is somewhere here. This is 1, 2, 3. Sorry, 1, 2, 3. 3 is somewhere here. Yes, this is first 0 number. So અહીંયા થી અહીંયા સુધીનું મારે distance જોઈએ છે. તો કેટલી થઈ? 1 lambda d upon d plus half. So this is nothing but x5 prime minus x3 is equal to 3 by 2 lambda d upon d. So 3 by 2 lambda is equal to 5,000 into 10 raised to minus 10 into capital D divided by small d 0.05 into 10 raised to minus 2. So this minus 4 is going up. So this becomes 3 by 2. Okay, I keep as it is 3 by 2. This is 5,000. કેટલા થયા? Minus 4, minus 6, minus 6 and minus 3. So 10 raised to minus 3. Okay, this is nothing but 1.5. still is pi is cancelled here. So this is 1000. Now is okay. 1.5 millimeter. So this is our answer. In younger double select, fifth bright fringe produced by the 4000 angstrom superposed on the fourth bright fringe of unknown wavelength. Find the unknown wavelength. So here very simple, we already discussed n1 lambda 1 is equal to n2 lambda 2. From that you calculate what is lambda 2, that is n1 lambda 1 upon lambda 2, sorry, n2. So what is n1? n1 is fifth one. So 5 into 4000 divided by n2 is fourth one. So this is 1000. So you will get 5000 angstrom. This is very simple formula. When they are superposed, you will always use n1 lambda 1 is equal to n2 lambda 2. In young double slit, the distance between two slits is 1 millimeter. Small d is equal to 1 millimeter. So is equal to 10 raised to minus 3 meter. Two consecutive bright fringes is 0.03. So you have given beta is equal to 0.03 centimeter is equal to 0.03 into 10 raised to minus 2 meter. Now displacing the screen away from the 50 centimeters. So I say suppose d1 is equal to d, then in second case d2 becomes d plus 50 centimeter. So it is in centimeter, so I convert into meter. Otherwise, I convert this into centimeter. I think this is best way. I don't want to convert here. But I write this is 10 raised to minus 1 centimeter. Okay. I keep all on centimeter. This is in centimeter. The distance between two consecutive dark fringes is double. So now this is beta is this much. So now beta prime becomes 2 beta. It means that 0.06 you can write. This is 0.03, so double is 0.06. Or you keep 2 beta, no problem. Find the wavelength of the light used. So we have formula beta is equal to lambda capital D upon small d, isn't it? And beta prime is equal to lambda d plus 50 upon d. We can use, in first case we have distance d, in second case distance is increased, so d plus 50. So beta prime, now but beta prime is equal to what? 2 beta is equal to lambda d plus 50 upon small d. So now we can either method, what I can do, I can subtract this 1 from 2, or I can put the value of all. I can calculate, is there a wavelength? No, so wavelength is to be calculated. What is the wavelength? So you have given d. So d is not given. So you cannot substitute the value, but I have to subtract 1 from 3. So if you subtract 1 from 3, what you will get? 2 beta minus beta is the beta. 2 minus 1. So beta is equal to lambda d upon d. This lambda d will cancel out. So you will get 50 lambda upon d. And which implies that lambda is equal to beta d upon 50. So what is beta? 0.03 centimeter. Small d is 0.1 centimeter divided by 50. So this is 3 into 10 raised to 1 to 3 minus 3 divided by 50. I multiply by 2, I multiply by 2. So you will get 6 upon 100, isn't it? 6 upon 100 into 10 raised to minus 3. So what you will get? 6 into 10 raised to minus 5 centimeter. So now you can convert into angstrom. So naturally this becomes 6000 angstrom. Okay. So this is answer is 6000. If the difference of time taken by two wave emitted from coherent source to reach a point is integer multiple of periodic time, okay, then you show that there is a construct interference will take place. So we know that construct interference can possible when there is a path difference is n lambda, or you can say that if phase difference is 2 pi integer multiple of 2 pi, whatever it may be. So we have to find out path difference in terms of wavelength. So આપણે એમ કહીએ કે suppose time taken by wave 1 is, I say, t1. Time taken by wave 2 is equal to t2. Suppose t2 is greater than t1, I can write t1 is minus t2 is equal to nt because it is integer multiple of capital T. સમજમાં આવ્યું? So t2 is equal to what? So distance upon velocity minus distance upon velocity, because velocity is same for both and distance is different. So this is one for source 1, source 2, this is the position. Okay, this is r2, this is r1. Now you can understand r2 upon time is equal to velocity, and r1 upon time is velocity. So time આવું થશે મારું is equal to nt, right? Therefore r2 minus r1 is equal to nt. C is common, I take it here. So this is nothing but 1 upon frequency, so it is n lambda. t is equal to lambda upon c. C will cancel out. So we can see that it is an integer multiple of wavelength. So here constructive interference takes place. Okay, if it half integer માં આવે તો અહીં destructive interference થાય. તો બસ maybe question may be asked like that also. Now it's very interesting problem here in this one. So we have two sources. S1 is here, S1 and S2, and point P is here. But this S, as you can see in the figure, this both are not equal. S2 minus S is 0.25 lambda. Both are not same distance. Okay, where lambda is the wavelength of the light used to obtain the condition for the constructive and destructive interference. We say that this is suppose R1 and this is R2. We know the relation what is for the constructive interference from S1 and S2, but we have not derived from S. So actually what is my path? Okay, actual path difference is equal to S1 S2P minus S1P. This is actual path difference. When the theory when we discuss, we use S1 S2, we are not focused on S. Okay, so this is the thing. So S2 plus S2P minus S1 plus S1P. So S2 minus S1 is already given. So this is 0.25 lambda plus S2P minus S1P. Now this relation we know. So this is 0.25 lambda plus, I can say, R2 minus R1. So if this equal to n lambda, it is constructive, it is equal to 2n minus 1 or plus 1, it depends where n starts. Okay, 2n plus 1 lambda by 2, then it is destructive. So now you can find R2 minus R1, take the other side. So it is lambda by 4 minus lambda by 4 minus. So this is very again interesting. આના આધારે ક્વેશ્ચન પૂછાતા હોય છે. આ તમને પાથ ડિફરન્સ આપેલો હોય છે અને એના આધારે અહીંયા આગળ કયા કલર માટે કન્સ્ટ્રક્ટિવ થાય, કયા કલર માટે ડિસ્ટ્રિક્ટ, that question can be asked. So this is again a very good problem. This is for, we are discussing for one monochromatic. So the source is a wide source, then at one point condition is satisfied for the red, for destructive, maybe not satisfied for the violet. Okay, it may be for constructive. So such type of question can be asked here. Then in a young double slit experiment, if the distance between two slits is double, then the wavelength of light used, okay, prove that 5 maximum bright fringe we can obtain. So here somehow we have to show that this is not possible and this is the possible. So what is given here? So you have given slit width, two slit is double than the wavelength. So you have given 2 lambda. D is equal to 2 lambda આપણને આપેલા છે. Okay, but we have one relation D sin theta is equal to n lambda for constructive interference. So to get the bright fringe, what is D? So D is equal to 2 lambda sin theta is equal to n lambda. We can write it therefore lambda is cancelled. So sin theta is equal to n by 2. Now which are the possible value of n? So we get the sin value within the limit -1 to 1. So n is equal to 0 માટે આપણને we get one fringe. For n is equal to 1 we get second fringe. 1 is possible 1 by 2. N is equal to 2 I will get second 2 more fringe up and down center માં એક અહીંયા મળશે એક અહીંયા મળશે. This is and this is so total becomes 5. 3 is not possible. N is equal to 3 not possible. Why? Because sine function cannot be more than one value. If you put 3 then it will be 3 by 2. 3 by 2 is 1.5. A possible, nothing, not possible. So maximum 1 plus 2 plus 2 means total 5 possible. Again it is good question. Okay, અહીંયા બીજું બી કંઈક આપેલું હોય, width તમે બીજી રીતે આપેલી હોય, suppose it is 3 lambda, then it n by 3, then you will get n 3 possible value બનશે, so you will get the 7 likewise. Okay, then I go for the next. In our young double spectrum beam of the light wavelength 6500 520, this is already discussed in the text in NCERT book. એ પ્રકારનો છે આ. Again same one, n1 lambda 1 is equal to n2 lambda 2. From that you find out what is n1 and what is n2, and from that you can find distance between two slit is this one. Then what is distance between the slit wave you have to find out ક્યાં આગળ બે સુપરપોઝ થશે. So you calculate n1 on n2, then lambda d upon d multiply by n1, then lambda 1, or you can say n2 lambda 2 d upon d. Both will be equal. આ પ્રોબ્લેમ આપણે કરેલો છે એટલે હું આમાં વધારે જતો નથી. You do at home by yourself. Okay. Okay. White light is used in a young double slit experiment as shown in the figure. At a point on the screen directly in front of slit S2. So generally we discussed for center point. Here the point is not center but in front of S2. Okay, this is a very good problem. Again, certain wavelengths are produced destructive interference, they are missing. જ્યાં destructive say this color is missing, and for constructive we can see it. Find this wavelength corresponding to first and second order diffraction. So here we have to find our first path difference. So path difference is S1p minus S2p is the path difference. Okay, this is your path difference. So how we can find out what is S2p? I think this is Pythagoras. We can use it. And you have given this condition also. This distance is very large. Sorry, this distance is large compared to this one. So how I can find it? So S1p is equal to, we can say, write that may check કર્યું, this is not the diffraction word, but it is a interference word. This is interference. So here path difference is equal to S1p minus S2p, and for destructive interference is equal to, we have 2n minus 1 lambda by 2. N is starting from 1. If I write 2n plus 1, then n starting from 0. Okay. See, there is not any clarity. The problem I have taken from the text where this formula is used, બંને સાચું છે, એવું નહીં કહેતા કયું સાચું છે કયું ખોટું છે. It depends on reference book. Okay, so I find out the path difference S1p. What is S1p? So S1p is equal to, you can see this Pythagoras. So I can write S1 S2, this is d square plus capital D square, and then root minus S2p is capital D. This is the path difference. So this d is very less than capital D, and use karo binomial expansion મારે કરવું પડશે. So I write d square upon d square plus 1. I write d square common with root, so it become d minus d. So this is using a binomial expansion. You can write it is that this becomes 1 plus d square upon 2d square multiplied by d minus d. So this is d will cancel out. So I will get finally d square upon 2d. This is the path difference. Path difference. And for district interference, we have 2n minus 1 lambda by 2. So n is equal to 1. N is equal to 1. This is lambda by 2. For n is equal to 1, lambda by 2, 2 is going to cancel. So wavelength becomes d square upon 2d. And if for n is equal to 2, then 2 2s are 4 minus 1 3, so it will be lambda 1 lambda 2 d square upon, sorry, this 2 to cancel, d square upon 3d. So this wavelength is absent. This wavelength is absent. समझ में આ wavelength absent હશે ક્યાં આગળ? આ point આગળ. આ કલરની wavelength દેખાશે નહીં. If you do calculation, this color will disappear here. બાકીના કલર તમને દેખાશે. જે condition m lambda ની સેટિસ્ફાય થશે દેખાશે અને આ કન્ડિશન જે અત્યારે આપણે કીધી ડિસ્ટ્રક્ટિવ માટેની એ સેટિસ્ફાય થશે દેખાશે નહીં. This is very good problem. એટલે ખાસ be careful. Then I go for this is not important one. Yes, in front of a diffraction, the wavelength of the light incident normally on the slit is d by 2, where d is the width of the slit. What will be the number of bright fringes formed and infinitely extended screen? So the same problem what we have discussed in this interference. So here also d sine theta is equal to m plus half lambda. So this is the condition for the maxima. So what is the lambda? Lambda is equal to d by 2. Okay, it is given. So this is d sine theta. So d is cancel out, and therefore sine theta is equal to m plus half divided by 2. So I put m is equal to 0. Yes, I can put 1. It is possible. I put m is equal to 1. 1 plus half. So 1 plus half 3. So it is 0.75. M is equal to 2. Then it is not possible. So for m is equal to 0, it is 1, and m is equal to plus or minus 1, we have 2, so total becomes 3. So 3 maxima is possible. Okay. Light of wavelength 5000 angstrom is incident on a slit of 2 mm in front of a diffraction. Find the width of the central maxima on the screen. Place at the focal point of convex lens of focal length. So to see the image, a very good image, we use convex lens. So this is the slit and we are using here lens, and this screen is placed always at the focal point. So this is your d is equal to f. D is equal to f. આવું આપણે થોડું ડિસ્કસ કર્યું હતું, and this is very close to this one. તો જે મારી શું જોઈએ છે second maxima, width of the second maxima. So whether it is interference or diffraction, width is equal to lambda d upon d. યાદ રાખી લઈશું. આમાં થોડું વેરિએશન થતું હોય છે, પણ generally you will get that much. થોડો ફેરફાર નહીતર હોય છે ખરો. When you go away from the central maxima, width is little bit decreases. Central maxima is with 2 lambda d upon d, and then lambda d upon d, then a little bit less, પણ આપણે એને કન્સિડર કરતા નથી. પણ you should know કે જેમ દૂર જઈએ તેમ width એ થોડી ઓછી થતી જાય છે અને intensity પણ decrease થતી હોય છે. Okay, so this is the d is equal to 100 centimeter, small d is 2 millimeter, and wavelength is 5000 angstrom. So you can do calculation very easily. So one more problem is very interesting. An apparatus of young experiment immersed in a liquid of refractor 1.33. The distance between the two slits is 1 millimeter, and that between the slit and the slit 1.33 meter. The wavelength is find the distance between two consecutive bright frames. Means beta is equal to, we know the lambda d upon d. This is our formula. But here apparatus is immersed in the liquid, so I have to use lambda in liquid. So this is nothing but lambda in air d upon refractive index of that liquid into d. So it will be less than the air. So lambda in air is 6300 angstrom. multiply capital D, that is 1.33 meter, divided by 1.33 is the refractive index, and small d is 1 millimeter. So 10 raised to 1 millimeter. Okay, 1 millimeter. So I put all these units. So 10 raised to minus 10. This is 10 raised to minus 3. So I can simplify this. So it's going up 10 raised to, so it will be 0.63 millimeter. So this is your first answer. This is now second one is very more important. Keeping the apparatus in the liquid. Liquid માં રાખેલું છે. One of the slit is covered with the glass plate. So when you covered with the glass plate, so path difference is changed, and because of the path difference is changed, first order dark fringe is displaced in the position of the zero order. તો મેં તમને ત્યારે કીધું તો આગળ એક પ્રોબ્લેમ આપણે કર્યો ત્યારે કે when you put one any transparent sheet, path difference change થાય તો જે shifting થતું હતું એ આપણે x ની આપણે ફોર્મ્યુલા બી ડિરાઈવ કરી હતી. તો what is the path difference? Path difference due to sheet generated. Path difference generated due to sheet. So ये आपने जोયું तो is nothing but thickness into n minus 1. If it is placed in the air, but if it is placed in the water, then I have to relative refract, means glass with respect to water. So T N G upon N W minus 1. This is the path difference because of that. એ કેટલું થાય છે? The first dark is replaced to center one. It means lambda by 2. It means is equal to lambda by 2. Again, which one lambda? So it is already in the liquid. So I have to use liquid. It means that N in R divided by refractive index of the water, here it is divided by 2. So now I want to find out what is the thickness, I think. Yes. So T ને મારે formula બનાવવો પડશે. So I write T is equal to, before that I simplify this Ng minus Nw upon Nw is equal to lambda in air Nw into 2. This is cancelled out. So I can calculate now thickness is equal to lambda in air upon Ng minus Nw into 2. So this is 6300 angstrom, 10 raised to minus 10 divided by Ng, that is 1.53 it is given, this is 1.33 is given, multiply by 2. So this you can simplify, it comes out 10 raised to minus 10, 63 divided by 2, so it is 3150 divided by 0.20. તો આને આપણે જો સિમ્પ્લિફાય કરીએ તો I will getting 6350 divided by 0.2 is equal to 31750 into 10 raised to minus 10. So this is in meter. So I cut 1, 2, 3, 4, 5. So this is 0.317 into 10 raised to minus 5 meter still. Okay. અને જો આને હું 10 raised to minus 3 માં કન્વર્ટ કરું, ઓકે, તો આનો બે આ બાજુ લેવાય. સો ઇટ ઇઝ આન્સર કઈ આપ્યો છે? આન્સર આપ્યો છે 1.57. Ng minus Nw કંઈક ભૂલ થઈ હોય એવું લાગે છે. lambda L divided by 2. Yes, this is not a 6, it is 3150. તમે કેલ્ક્યુલેશન કરજો, આવી જશે 3150. You divide by 0.2, it becomes 15750 into 10 raised to minus 10 meter. Now whatever the require, you can do conversion. અહીંયા આપ્યું છે તમને 1.57. So I can write 1.575 into 10 raised to minus 6 meter. Okay. So this is very good problem and you can do it. Okay, અહીંયા સુધી આપણે રાખીએ છીએ. Thank you very much.